When NASA finally turned its $10 billion space telescope toward a tiny, fast-moving object racing through our solar system, nobody expected the numbers that came back to break the scale scientists had been using to measure comets for decades. This wasn't a rumor. It wasn't a leaked report. It was cold, hard spectral data pulled straight from one of the most powerful instruments humanity has ever built, and it revealed a chemical signature so unusual that researchers had to double-check their own equipment before they believed what they were seeing. This is the story of what James Webb finally detected on 3I Atlas and why it left NASA scientists genuinely surprised. To understand why this matters, you have to go back to July 1st, 2025, when a survey telescope in Chile, part of the asteroid Terrestrial Impact Last Alert System, or ATLAS, spotted a faint object moving through the solar system on a path that immediately stood out. Unlike the asteroids and comets we're used to, which loop around the sun in predictable repeating orbits, this object was moving on a hyperbolic trajectory, meaning it wasn't bound to our sun at all. It came from somewhere else entirely, passed through, and would never come back. Astronomers quickly confirmed it as only the third interstellar object ever detected in human history, following the strange cigar-shaped Oumuamua in 2017 and the more ordinary comet Borisov in 2019. This new visitor was officially named 3I Atlas, and it immediately became one of the most closely watched objects in the sky. Almost every major observatory available took a turn studying it. The Hubble Space Telescope captured images. The Spherex Observatory gathered infrared data. Ground-based observatories around the world tracked its position and brightness night after night. But the moment scientists had really been waiting for came on August 6, 2025, when the James Webb Space Telescope finally pointed its near-infrared spectrograph instrument directly at 3I Atlas to capture a full chemical fingerprint of the gas surrounding it. Spectroscopy works by breaking light down into its individual wavelengths, and different molecules absorb and emit light at very specific, identifiable wavelengths, essentially leaving a signature behind. When Webb's data came back, that signature was unlike almost anything scientists had seen from a comet before. What Webb found was a coma, the cloud of gas and dust surrounding a comet's icy core, dominated overwhelmingly by carbon dioxide. Researchers measured the ratio of carbon dioxide to water in that coma and found it sitting at roughly 8-1, an extraordinarily lopsided number. For comparison, most comets that formed inside our own solar system release far more water vapor than carbon dioxide as they warm up near the sun, since water ice tends to be the dominant volatile material holding a typical comet together. Finding a comet where carbon dioxide so thoroughly outweighs water was described by the research team as among the highest such ratios ever recorded, sitting more than 4.5 standard deviations above the normal trend, seen in large enough that statisticians would call it almost impossible to explain as ordinary variation. Alongside the carbon dioxide, Webb also detected water ice, gas phase water, and carbon monoxide, along with a tentative hint of a molecule called carbonyl sulfide, giving researchers an unusually detailed chemical inventory for an object that had only been discovered a few weeks earlier. Interestingly, the observations also showed no visible tail or jets at that point, even though the coma itself extended out to roughly 23 kilometers from the nucleus, a nucleus that separate Hubble measurements suggested was only about 2.8 kilometers across. In other words, this small icy core was pumping out an enormous, disproportionately large cloud of gas relative to its own size, and that gas was heavily skewed toward carbon dioxide in a way that didn't match anything in the existing comet playbook. Researchers offered a few possible explanations for why 3I Atlas might be built this way. One theory suggests the object's ices may have been exposed to unusually high levels of radiation during its long, multi-billion-year journey through interstellar space, altering its chemistry before it ever reached our solar system. Another possibility points to where exactly it originally formed within its home star system. Every young star is surrounded by a protoplanetary disk, a swirling ring of gas and dust from which planets, comets, and asteroids eventually form. And within that disk, different molecules freeze into ice at different distances from the central star, based on temperature. Water ice tends to form closer in, while carbon dioxide ice tends to freeze out further from the star, along what's called the CO2 ice line. If 3I Atlas formed particularly close to that specific boundary, it could naturally end up at the beginning, billions of years before it ever crossed paths with our sun. That detail alone would have been a fascinating scientific first, but the surprises from Webb didn't stop there. As 3I Atlas made its closest pass by the sun on October 29, 2025, and then began moving back out into deep space, scientists brought James Webb back for a second look in mid to late December, roughly 2 months after that closest approach. This time, Webb's mid-infrared instrument picked up something nobody had confirmed on this object before, clear evidence of methane gas escaping from the comet. The European Space Agency, working alongside NASA on the observation campaign, described the moment somewhat playfully, noting that Webb had essentially sniffed out methane venting from the interstellar visitor as it continued its outbound journey. What made that methane detection particularly notable wasn't just that it was there, but how much of it there was relative to water. The amount of methane measured compared to water vapor was surprisingly high, next to what's typically seen in comets that formed inside our own solar system, echoing the same unusual pattern already established with the earlier carbon dioxide. Readings. According to the European Space Agency's own summary of the findings, both the high methane ratio and the high carbon dioxide ratio together point toward a very different formation environment and chemistry than the vast majority of comets that originated within our solar system. In plain terms, this object wasn't just visiting from somewhere else, its actual ingredients were assembled under conditions our own solar system never experienced. Then came the finding that really reframed the entire story. On June 22, 2026, researchers published a peer-reviewed paper in the journal Nature laying out their full analysis of everything Webb had gathered. And buried within that chemical data was a method for estimating just how old 3I Atlas actually is. By working backward from its unusual mixture of ices and gases, and scientists estimated that 3I Atlas likely formed somewhere between 10 and 12 billion years ago. To put that in perspective, our own solar system is generally understood to be around 4.5 billion years old, meaning this small, unassuming chunk of ice and dust drifting silently through our neighborhood is nearly. Sit with that idea for a moment. The carbon dioxide, the methane, the water ice detected by Webb wasn't just unusual chemistry, it was our own sun ever ignited. Every molecule Webb identified had been drifting through interstellar space for billions of years, surviving the crushing cold and radiation of the empty gulf between star systems, only to briefly light up as it swung past our sun and got close enough for our instruments to finally read its ingredients. Naturally, a discovery this strange didn't stay confined to quiet academic papers for long. Some researchers, including Harvard, astrophysicist Avi Loeb, had already been closely tracking 3I Atlas for other reasons, pointing to its unusual size, its forward-facing glow, and a period of unexplained non-gravitational acceleration detected as it approached the sun, all of which fueled public speculation about whether the object could be something more than a natural comet. The James Webb chemistry data didn't confirm anything artificial about the object, and the overwhelming consensus among scientists remains that 3I Atlas is a genuine, if remarkably ancient and chemically unusual, interstellar comet. But the sheer novelty of its makeup did reignite public fascination, with some researchers even floating the intriguing idea that ancient interstellar objects like this one could, in theory, help deliver the basic chemical building blocks associated with life as they drift between star systems, seeding raw ingredients across the galaxy over unimaginable spans of time. What makes all of this genuinely remarkable isn't a single dramatic headline moment, it's the sheer amount of confirmation. This wasn't one telescope catching a fluke reading. Ground-based observatories, the Hubble Space Telescope, the Spherex Observatory, and finally the James Webb Space Telescope all independently gathered data pointing toward the same conclusion, that 3I Atlas is chemically unlike anything that formed in our own solar system, and old enough to have been drifting through the galaxy since long before Earth existed. 4 powerful, independent instruments effectively agreeing that this object is, in the words of one research summary, genuinely bizarre by every normal comet standard we have. For NASA and the broader scientific community, that combination of confirmation and mystery is exactly why 3I Atlas became such a priority the moment it was discovered. Interstellar visitors like this don't come around often, and each one offers an exceptionally rare direct sample of material from a star system humanity will never be able to visit. Webb's detection of that carbon dioxide dominated coma, followed by the surprising methane reading months later, and finally, the staggering age estimate pulled from that same chemistry gave scientists more information about conditions in another star system than almost any other single object ever studied up close. It's worth pausing on how quickly all of this actually happened, because the timeline itself is part of what makes the story so compelling. 3I Atlas was only discovered on July 1st, an incredibly fast turnaround for one of the most heavily requested and carefully scheduled telescopes in the world. Getting Webb time typically requires proposals submitted and reviewed months or even years in advance, but interstellar objects like 3I Atlas qualifies for special rapid response observing programs precisely because they're so rare and so fleeting. Once an object like this is confirmed, astronomers know they may only have a matter of months before it becomes too faint or too distant to study in meaningful detail, so schedules get rearranged, priorities shift, and some of the most in-demand Instruments on the planet suddenly get pointed toward a single small object racing through the dark. That urgency paid off, because Webb managed to capture that first chemical snapshot so early. While the comet was still a healthy distance from the Sun at just over 3 astronomical units, researchers were able to establish a clean baseline reading of its coma before solar heating had a chance to dramatically alter its behavior. That early data became the anchor point for everything that followed, including the later December observations that caught the methane signature and the eventual analysis that pushed the object's estimated age back more than 10 billion years. Without that fast initial response, much of the detailed chemistry that made 3I Atlas so scientifically valuable might never have been captured at all. Oumuamua, spotted in 2017, was so oddly shaped and moved so unexpectedly that scientists barely had time to gather any data. Borisov, found in 2019, behaved much more like a typical solar system comet, giving researchers a useful but relatively unremarkable comparison point. 3I Atlas turned out to be the perfect middle ground, active enough to produce a rich, detectable coma packed with information, yet strange enough in its chemistry to stand out sharply. Became the first interstellar object with a coma detailed enough for Webb to build a genuine chemical profile around. None of this would have been possible without Webb's specific instrumentation either. Its near-infrared spectrograph and mid-infrared instrument are precisely the tools needed to detect faint traces of gases like carbon dioxide, methane, and carbon monoxide from tens of millions of miles away, picking apart infrared light with a level of precision no ground-based telescope can match. Earlier generations of space telescopes simply didn't have the sensitivity or wavelength range to pull off this kind of detailed chemical breakdown on an object this faint and this far away, which is part of why so many of the specific numbers involved, the 8-to-1 carbon dioxide ratio, the 4.5 sigma statistical anomaly, the surprisingly high methane content, only became possible to measure once Webb entered the picture. Even NASA researchers directly involved in the observation campaign described the results as genuinely unexpected, noting that they went into the August readings anticipating a fairly standard cometary chemical profile and instead walked away with numbers that forced them to reconsider what a comet forming outside our solar system might actually look like on the inside. 3I Atlas has already begun its long journey back out into interstellar space, continuing outward on a path that will eventually carry it beyond the reach of even our most powerful telescopes, never to return again. But the data it left behind, sitting in Webb's archives, will keep scientists busy analyzing its ancient, unusual chemistry for years to come, slowly piecing together a clearer picture of just how different and how old the ingredients drifting between the stars can really be. If stories like this make you want to keep exploring the strange discoveries hiding just beyond our own solar system, make sure you like this video and subscribe, because there's a lot more of the universe's unexpected chemistry still waiting to be uncovered. Until then, 3I Atlas keeps drifting outward into the dark, carrying billions of years of secrets that James Webb only just barely managed to catch a glimpse of before it was gone.